Hi guys, in the name reactions and mechanism category, we will discuss a new reactions called Appel reactions. What is that? When an alcohol undergo reactions with the triphenyl phosphine and carbon tetrahalide, it produce the alkyl halide. This halide may be the chloride, bromide and iodide. Now, this is the CX bond formation reactions, and these reactions happen under mild reactions condition. And this is the Appel reaction comes according to the scientist name Appel. So, what is the mechanism of this reaction? This triphenyl phosphine first undergo reaction with this carbon tetrahalide. First is attacked to the halide one atom, and that carbon halide bond gets breakdown, generates that ppH3 plus X, and further the counter anion CH3 minus. That CH3 minus undergo the proton abstraction from alcohol and produce that CHX3, also this alkoxide anion. That alkoxide anion further reacts with this ppH3 plus X minus, and that X as a leaving group it leaves out, so it gives the RO ppH3 plus. Now this X minus which leaves out, that's now acts as a nucleophile. It attacks to the R. This is basically R is equal carbon center, and finally the POPH3 leaves out. So the product formation is the RX with POPH3. Now this RX is the alkyl halide. So this is the overall mechanism of this Appel reactions. We can see what this happen in this reaction, as this X minus as a nucleophile approach backside towards this leaving group. Now this is the SN2 type reactions, and stereochemistry will be the inverse that of the leaving group, that initially it was the OH. So we will see some example of this. We can understand the first one, where this alcohol group was the equatorial of this system in this molecule, and under this Appel condition that alcohol to alkyl halide form, where halide as a bromide, it comes as a axial position as inversion of stereochemistry happen. This is the example number 2, where the alcohol is the bottom phase. So now after the reaction the halide form, it is from the up phase, so stereochemistry get inverse. This is the third reaction, where also that stereochemistry from alcohol to halide is inverse. Fourth reactions, where this acid to acyl chloride form. How this happen? Here that O ppH3 plus formed happen, intermediate kind of thing, and then that chloride minus attacked, giving the acyl halide. This POPH3 leaves out like same way. And this is the reaction 5, where the stereochemistry of the hydroxyl was the upward. Now in the product, where alkyl halide is the bromine downward phase. Example 6, where this cases the similar intermediate form and further reacts with the NH2 group as a nucleophile. This POPH3 leaves out and giving this amide kind of thing. Further this OH also undergo Appel kind of reaction, generates this, and this further from this amide bond cyclization happen through oxygen center and gives this cyclized product. Now this also intermediate this side happen formation, and further this NH2 acts and POPH3 leaves out, gives the cyclized product. In these cases we have seen not only the ppH3, that any phosphine also undergo reaction gives the similar type of product, that also stereochemistry gets inverse in the product. We have used the we have seen the how stereochemistry get inverse for product, but if there is the primary alcohol present in the reaction, that cases primary alkyl halide from, there is no stereochemistry, so product also don't have the stereochemistry. Now there is one modification where we can use the catalytic amount of phosphine, and that cases the stoichiometric amount of oxaloyl chloride should be used. Earlier all the reactions that PPHC and carbon tetrahalide used in the stoichiometric amount, but this cases if we use that triphenyl phosphine as the catalytic amount, then that undergo reactions also initially this catalytic amount carbon tetrahalide produce this compound here PPH3 plus Cl and counter, and that undergo reactions with the one alcohol produce this product and further generates the triphenyl phosphine oxide, and that triphenyl phosphine oxide undergo reactions with the oxaloyl chloride further gives this halide PPH3 plus, and it's through cyclic way that generates again product. So this is the one modification have of this Appel reaction. So thank you.